Okay, so in this video, we are focusing on the understanding of the relationship between population and sample, and building the vocabulary to understand what is the definition for population and what is the definition for sample, and other related statistic terms. Okay, so since the chapter 1, I already start talking about, hey, sample, hey, population, but we never actually truly define what is population and what is the sample, and also when we need to use the sample data and when we should consider use the population data. Okay, first of all, let's explain what is population. So population is all of the items that we are interested in, maybe neither finite, like all the passenger on a particular airplane, or if effectively infinite, such as all the Coke's product produced in the ongoing bottling process. So basically, all our research we care about is population, right? Think about when you're developing a new product, you want to understand the preference of all your customers, and so all your customer, but it might be unlimited. Your customer can repeat purchasing your goods, and newborn buy your goods, and people die, pass away, etc. So that population, regardless what scenario, is the one you really care about, right? And then so the population is everything. Every individual, all items. But when we look at the sample, so the sample is a subset of the population that we will actually analyze. So if, as we're talking about the customer of a product, it's infinite. You can have so many, cannot say infinite, it's so large, the sample size is so large, you might not be able to get all the information from them. So instead of asking every of your customer, you might find a group of your customer to getting their feedback about your product, right? So that group of customer is called a sample. But here in this definition, I do want to emphasize the sample is not any small group of your customer. It has to be a subset, means they need to be able to represent your population. So for instance, your product a customer have a senior, have a teenager, have baby, they all consume your product. So when you collect your sample, you cannot say I only have a senior in my sample. So if that's the case, it's not a subset, and that says you have a very biased sample, right? So the sample and the population. So basically, sample is a part of your population. Okay. Now we look at the sample or the sensor. So a sample or sampling, or actually say a sampling, involves looking only at the some items selected from the population. And a sensor is an examination of all items in a defined population. And so basically the sensor is the way we use to collect the data from population. And the sampling, I should change this E to ing, okay? The sampling is the method you use to get the data from your sample. Okay, so here I have the question. Sensor usually being used when we look at the U.S. sensor, right? We call U.S. sensor survey. Every 10 years, everybody in the population need to finish. So that is one of the few example that we can call the data we're collecting through the sensor. And so why only the United States can do that? So first of all, we do have a law to require all the people has to finish the sensor. They did talk about penalties, but I don't think they ever enforce it. But we do have the consequences if you don't fill the sensor. And again, the sensor not happening every year, usually every 10 years, and then. So only the government have that like enforcement to getting the data from everybody from the population. Okay, so now here's why can the United States censor every person in the population? So that means when we think about censor, ideally it will be able to collect the information from everybody, but the censor does have a weakness. Okay, so here are a few weaknesses when we talk about U.S. censor survey. So the mobility, people move around, and they might not get the censor survey. And also we have undocumented worker, they will never get in a census survey. And also the budget constraint. As you think about if this survey requires everybody in the United States to fill in the survey, how about we have the budget cut? They cannot mail all the paperwork, and what's going to happen? And also incomplete responses. And some people gather the sensor, they don't care, they just put a random answer on it, right? So all those can be the weakness of the sensor, right? Okay, so here bring up the question, when should we consider use the sampling method? When should we use the sensor? So basically, when should we collect the data directly from the population? When should we just collect data from the sample? Here are some tips. So when a sample may be preferred. So when we have infinite population, so huge population, Like we're talking about assembly line can keep producing cars. It does not make sense to check every quality of every car, right? It's impossible and very cost ineffective. And the second is called destructive testing, right? So here I give you example is the like a battery life, vehicle crash test. You cannot test every vehicle to use the car to crash on the wall. So who can buy the new car anymore, right? And also when I work at Washington State, they try to understand the consumer. They do experiment on the apples. So they create a new species of apples in terms of taste and the texture. So usually they just grab some apple from the tree. So can you imagine they said we're going to test out the whole population. So basically you're going to have a bite of every apple. So that's impossible, right? So that considered as a destructive testing. And then another scenario we need to use sample is a timely result. As we're talking about sensor, take a time. You need everybody in your population to fill in the survey or getting data from everybody in the population. But if you need a quick result, so it's impossible to do sensor, then you're going to rely on the sampling, getting the data from the sample. And also accuracy. So instead of spreading resource time thinly to attempt the sensor, budget might be better spent to improve the sampling. So if you are able to use the right sampling technique, you are actually able to get a better data quality than the sensor data. Okay, later we're going to talk about different kind of sampling technique. And the cost. If you want to save cost, as you know, if you need everybody in your population share the data with you, it is very costly, right? So if you have limited budget, so sampling method will be your to-go method. And also the sensitive information, such as the sexual harassment, might be the best be studied by selecting the in-depth employee interviews versus ask everybody, right? Okay, all this thing telling us sampling is a good way to do it. However, in certain situations, we might do sensor. First, if your sample size, your population sample already small, so you only study 50 total people, don't try to create a sample because you're already small enough. So just go ahead getting information from each individual in your population. And also the large sample size, if the required sample size approaches the population size. So let's say if they require 10,000 and you have 10,005 population size. So you'd better just go get the data from your population, right? And also the database exists. If the data are in the database, we can examine all the cases. So for instance, when I was at Capital One, they documented all the applicants' data. So since I do have all the data, why not just go ahead and analyze it versus selecting the data, right? So if you do have a huge database, and go ahead just based on that to do the work. And another one is the legal requirement. So the banks must count all the cash in bank teller drawers at the end of each business day. So for some legal requirement, the data you recorded become the population data, and then you just go ahead and use it directly. Okay. After we know what is the population sample, sampling method, and also the sensor, now we move on another pair of concept called parameter and the statistic. So for the parameters, so the parameter always map back to your population. So basically, parameter are the characteristic of the population, and another mirroring concept is statistic. So the statistic is the characteristic for a sample. Okay. Usually unknown the parameter for the population. Again, parameter always going to be for population. They're unknown because we can't really observe entire population, and so we usually use Greek letter to symbol the parameter. Later, we're going to look at next chapter when we do some kind of calculation. Pay attention on the notation. And then the statistics used to characterize the sample. And always keep in mind that for the statistic, we're going to use the English letter. Okay, so the parameter we're using Greek letter and the statistic we use English letter. And so okay, so from the sample of an item chose from the population, we compute a statistic that can be used as estimate of the parameter found in the population. And to avoid confusion, we use different symbol for each parameter and its corresponding statistics. We're using our Greek letter for our population parameters, and we're using English letter, usually with some weird symbol on the top to symbolize the sample statistics. And the population portion here is denoted by pi, the lowercase Greek letter pi, while the sample population is p. Okay, here we want to also distinguish between population and the target population. So the population must be carefully specified, and the sample must be drawn specifically so that the sample is representative. And the target population is the population we are interested in. And then the sample frame is the group from which we take the sample. So here's an example. I had a student work on a project before. They tried to understand the college students' time spent, how many coffee they drink, how that affecting their sleeping hours. So that is their research question. So when they started collecting data, so they went to Edinburgh campus and they surveyed 50 students and asking them about the hour they sleep and how many coffee they drank. And so when I asked the student, I said, do you really think your sample are able to represent your targeted population? And he said, yes. I said, how so? You care about the U.S. college student, but the sample you have are actually not just about Edinburgh campus student. He only surveyed 50 business Edinburgh student. I said, hey, I think you need to rethink about your target population. Sounds like your sample only can representing the business student in Edinburgh campus, right? So therefore, he changed his research population and rewrite his research project. Okay, it is very important when you are thinking about your population and the relationship with your sample. And your sample has to be able to represent your population. Okay, before we move on to our practice question, I want to summarize the concept we just learned in this part of learning objective related to the population, sample, sampling, statistics, sensor, and so to make sure you are able to connecting all of them together. So here's the idea. So we always care about is our population. And then the way the population are got characterized is called a parameter. So for our parameters, usually it's be symbolized by some Greek letters, such as mu, we're going to learn later, and the sigma. And then, so as we know, in order to get information about our population, we need to use the sensor to collect the data. So the sensor is the method we use to collecting the data from the population to figure out the value for our parameters. However, it's very costly, we know, to get information from the population. So therefore, we're going to count on our called the sample. And the sample is the subset of our population. Okay, so the sample has to be able to represent our population before you can say, hey, this is a good sample. And so based on the sample, we are using the sampling method. Sampling. We are using the sampling method to getting the information called a statistic. So basically, statistic is like our parameter. So parameter is characterizing the population, and our statistic is characterizing our sample. So for our statistic, we are using the English letter, sometimes with some weird symbols. If I spell it right, symbols. Okay, symbols. So for instance, as X bar and S. Okay, we're gonna look at them in our future chapter. So statistic. Okay, statistic is used to characterize the sample. We're using the sampling technique to getting the information from our sample. Okay, so eventually we are able to use our statistic as an inference to refer to the value for the parameter. That parameter is used to characterize the population. You can see this detour, right? Sometimes we can just directly get in the parameter's value to characterize the population, but most of the time we're going to detour and getting sample first and figure out the statistics. And then if the statistics go through some hypothesis testing to make sure it's a good inference to our parameter value, and then therefore it will be able to understand how the population should look like. Okay, so this is the overview about what we just learned, different concept: population, sample, sensor, sampling method, statistic, and the parameter. And so next we're going to work on is a practice question. Okay, so here are the question. Would you use a sample or a sensor to measure each of the following and why? So the model years of the car driven by each of your 5 close friends. Should you use a sampling method or a sensor? Okay, so here, now you already identify your population. You only care about your 5 close friends. You didn't say you need to know all your friends. So you maybe have unlimited friends, but here obviously you are not try to understand all your friends. You only try to understand your 5 close friends. So this 5 close friends is your population. It's a small sample size, small population size. Therefore, there is no way you need to use the sample method. You can just go ahead and ask all 5 close friends. So therefore, A, you're going to use a sensor method because a small population size. B, the model years of the car driven by each student in your statistic class. Okay, so for our class at the Penn West, we don't have a really large class. So we only have 30 students. I think 35 is the cap. So therefore, you only have 35 students. It's again still considered as small population size, right? And then so therefore, there is no need to sampling them. Therefore, you can just go ahead, just ask all your 35 classmates, hey, what model year of the car you are driven, right? So in this sense, question number B, you're gonna choose a sensor. A sensor again, yes, because the small size of your population. Last one, the model years of the car driven by each student in your university. Okay, so we have 10,000 students, and then if you think that's a good idea to ask everybody, then go ahead, do it. However, the common sense here is not asking everybody in our university. Instead, you should sampling 30 to 50 students and ask them the model year of the car they driven, because the larger size of your population. So the number C, the best option is to do a sampling, okay, instead of use population. Okay, so A, B, the answer is sensor, and C, the answer is a sample. The main reason is because the size of your population, whether they are small or large. Okay, so good luck with your homework and feel free to reach out to me if you have any question.